Hi everyone, this is the lonely integer problem by HackerRank. The link to the problem will be in the description. It says, given an array of integers where all elements but one occur twice, find the unique element. This is the example we're given, and as you can see, 1 appears 2 times, 2 appears 2 times, 3 also appears 2 times, but 4 only appears 1 time. So that is the lonely integer that we are returning. These are our constraints. So it's saying that the size of our array can be 1 or greater, but less than 100. And it is guaranteed that the size of our array is an odd number and that there is one unique element. The elements in our array can be anywhere from 0 to 100, where 0 is less than or equal to I and I is less than n. This is our solution. So our first step is to get the counts using counting sort. So counting sort is a sorting algorithm, and the size of our array that we're using for counting sorts should be size of 101. And I'll be doing a walkthrough on how we're going to be implementing this. If you'd like to just have more knowledge, in-depth knowledge of what counting sort is, I'll be posting this in the description. There's also a HackerRank problem that's specifically just about implementing this sorting algorithm. And I'll be posting another video on solving this. So, after we get the counts using counting sort, we will find the lonely integer. And the lonely integer is going to be our counts index where count equals 1. Let's do a walkthrough. Let's suppose this is the array that we're given. The first thing we're going to do is to initialize our counts using counting sort, and it's going to have 101 elements. So each of these are indexes right here. So this is index 0, index 1, index 2, index 3, all the way to index 100. So let's get our counts. So the first element in our given array is 1. So we are going to increment the count at index 1. Then the next element in the given array is 2. So we increment the count at index 2. The next element is 1 again. So we increment the count at index 1. And then the next element is 3. So we increment the count at index 3. The last element is 2, so we increment the counts at index 2. Cool, so we've gotten all of the counts for our given array. Now we want to find the lonely integer. So we do this by going through all of the counts in the counts array. So if it's equal to 0, then we can ignore it because it appears 0 times in our given array. If it's equal to 2, it's not our lonely integer because that means it has a pair. So this 2 at index 1 means there is 2 1s in our given array. Okay, there's 2 2s, so we can ignore that. But there is 1 3, so that means that is our lonely integer. And that's it for the walkthrough. Go ahead and pause the video, try to solve it on your own, and then we will solve it together. Okay. So let's code the solution. The first thing we want to do is initialize our array of counts. And this array is going to equal 101 elements, right? Which means the index is going to be 0 to 100. And in Java, when you initialize a primitive array, such as integer, then all of the counts are going to be set to 0. Now, we will loop through our given array. So we're going to say for our integer current number of our array A, right? And that for loop is the same as saying for int I equals 0, while I, our index, is less than the size of our array. We'll increment 1, and then we'll say current number is equal to getting the index of this array. So these two for loops do the same thing, but we're going to stick with the first one. So we're getting every number of our array, and we will add that to our count. So we're going to use that number as the index of our count array, and we will add 1 at that index. Awesome. So now that we've counted all of the numbers of our array, the next thing we want to do is find the lonely integer. So we're going to say for int I, while I is less than the length of our array, and we're going to get the count at index I, and if it equals 1, then that is our answer. So we would return I. And you always have to have a return value. So in case for some reason we did not find the lonely integer, we're going to return -1. And if we get -1 as our answer, then we know something went wrong with our solution. So let's copy and paste this into HackerRank. Submit the code, and everything passes. Okay, so go ahead, take a moment, and solve for the time complexity and space complexity of this solution. So the time complexity is asking what is the relationship between our input and how long it takes to run the code. So this is not dependent on our input, right, in terms of our runtime. And this for loop is, right? So for this for loop, we're getting every single element of our given array. And the number of times this for loop runs is O of n times, where n equals the size of array A. And then we have another for loop, and this is going to run for the length of our count array, right? And we know that the length of our count array is 101 elements, but that is not dependent on the size of our given array. So there's no relationship between this for loop and our input, right? This will always run 101 times. So this is constant runtime. Doesn't matter what our input is. If this list array, if the size of this array is 1,000,000, this loops through 101 times. If the size of this array is 1, this will loop through 101 times. So that's why this is O of 1. So our total time complexity is O of n, right? Because of this for loop here. And that's where n equals the size of our array. Now for space complexity, we're asking, is there a relationship between our input and how much space our method uses? So we have our count array, and this is of size 101. But does this size change based off of our input? It does not. So once again, regardless of the size of this array, this will always be 101. So this is constant. And that's the only variable that we need to be concerned with, right? We are creating a variable here, but this is one single variable. So this is also O of 1. So both of these variables, we only have 2 variables in this whole method, and both of them are O of 1. So our space complexity is O of 1. It's constant. That concludes the solution for lonely integer. Thank you guys for watching. If you have any questions or feedback, please let me know in the comments. Thank you.